but it would be more of an introduction which would help you to understand what Industry 4.0 is and to understand what is the core of the Industry 4.0. Right. So here we move ahead. This concept of Industry 4.0 or I 4.0 as it is popularly referred to was unveiled in 2008 in the at the Hanover Messe Fair in Germany. The concept is manufacturing systems are vertically networked with business processes within factories and enterprises and horizontally connected to dispersed value networks that can be managed in real time from the moment an order is placed right through to outbound logistics. Now, this was the vision that German government gave as its high-tech strategy sometime in 2008, April of 2008. And the crux here is knowing the state of your business in real time all the time. Right now, you have ERP, MRP, and all those things which connect everything else other than the shop floor. But the real value addition in any business takes place on the shop floor. And the data from the shop floor that flows into the system has got a lot of lag because probably it's collected at the end of the shift. Then it is scribbled on some pieces of paper. Then the paper goes to your ERP, your IT department. Someone punches in that data, and by the time it comes up, it's probably 48 or 50 years old. So to avoid all this, Industry 4.0 is something which where we try to connect the shop along with the ERP and MRP. That's the basic concept of Industry 4.0. Uh, See, let's start with some uh, right from basics. Earlier, when the man was in uh, Ice Age and Stone Age, and then it started progressing into a society, the men started making some kind of tools, basically out of either wood or stone, to protect themselves, to kill animals so that they could eat, and probably to carve caves and something of that sort to stay in. So, and then as the society progressed, they started painting within inside the cave. Then they started putting some kind of scriptures inside the caves. But still, they were restricted to making some kind of tools for their own protection and that kind of thing. And I would put this as the industry, the zeroth revolution in industry, because the invention of wheel gave the sense of continuity within a confined shape. It's the if you rotate the wheel along its axis, you can get a continuous straight line. I mean, you can have a continuity within the confined shape. So that was quite a revolution in those days. Nowadays we see wheels everywhere around, but in those days that was a big revolution, and that's where the uh, art converted into kind of science, I would say. Then came the first industrial revolution. Now, this first industrial revolution uh, basically is invention of steam and boilers and steam engines. And why it is called as revolution? Because before that, any kind of mobility, you needed animals or men or living beings to put you to take you around. Now, with invention of steam engines, it was possible for humanity to move around without the help of animals. The As you see, we'll just go through one clip and you'll know something about it. This was first industrial revolution where the mobility became free of animals. See, the train looks more like horse-driven coaches connected together. look at the speed; it's so slow that even a doggy following along. Look at the tracks; they're, I mean, all up and down, and still it's working fine. So it's kind of what we call jugaad nowadays. In those days, that was the level of sophistication that could be achieved. And there are a few funny things that will happen in this clip, and let's try to enjoy them. Here is a curious donkey who wants to know what is going on. He has never seen this kind of a thing. Not ready to budge. So it's easier to move the rails. And here we go. Look at the level of sophistication in those days. It was so primitive. You can find two guides in front of the front wheel to keep the maintain the gauge of the rails. Look at the flexibility of the coupling between the two coaches. Yes, he's satisfied. One. It's nowhere near today's railways. Here is a bridge, and wow, see what has happened. You can see a similar bridge in Uti on the Metropolitan Uttarakhand railway line. I've gone through this bridge in Uti, and such similar things do happen even today in India. The trains are of course much better. So this was Industry 1.0, and this was a technical revolution. The second industrial revolution which came up was more of a management revolution because this was when the operational management got refined, and the three S's of operational management: standardization, simplification, and specification, they became prominent. And the things were standardized to such a level that you have that famous quote from Henry Ford, which says that we can give you car of any color till the color is black. So it was standardized. I mean, Ford T model was the first mass-produced car in the world, and it was produced on what the way the today's cars are produced on an assembly line with a conveyor, and the conveyor keeps moving at a constant pace, and people are standing all around it and adding new components, and the car comes out at the end of the conveyor. Uh, but there are certain things that give you problems in this kind of thing, like monotony in the job becomes too much, and then people have issues with that also. Let's enjoy another clip from uh, Charlie Chaplin's Modern Times. This is the conveyor line, and there are people standing around it and doing the job. See what happens. The monotony turns people into crazy things. Look where he's gone, and the fellow is still working. Thankfully, he's out. And he's gone crazy. The lady is smart. Diverted his attention. Anyways, uh, this was a time when industry and commerce got together. I mean, there was a agreement signed by 44 countries at Bretton Woods in US in 1944, and that's when the macroeconomy and integration of the economy and industry started at this moment. And this was when actually the industry and economics both started proliferating. Now, after this came Industry 3.0, third revolution. Third revolution is again a technical thing, and it was marked by the advent of advancements in electronics industry when the uh, things started converting from walls to transistors and transistors to ICs. Miniaturization started taking place in the electronic circuitry. During this time, uh, the computers and operational technologies moved ahead in two different silos, and that's where the problem for was created. Now, what is Industry 4.0? Industry 4.0 is basically confluence of cyber physical systems and humans. Your cyber systems will have computers, ERP systems, and so on. Your physical systems have machines and different equipment which you use for producing the product. And you have human managers, operators, staff. So now, when you want to, Industry 4.0 is confluence of all these three things together. And to get that, what we need is something called an edge node device and a gateway. Now let's talk about edge node device and a gateway later on in detail. But these are the devices which connect the three together, and that's how you can manage the systems much better. And this confluence leads to lends itself for automation very well. And then you can automate your operations and management, both the systems together seamlessly using your ERP and other things. Uh, you need Industry 4.0 basically because the world is a VUCA world, as they say, volatile, uncertain, complex, and ambiguous. And to mitigate that, you need data. So data is the new oil. That's we keep hearing data is the new oil all the time. So why data is the new oil? Because it lubricates your systems, uh, it, fuels your systems, so that the economy that we are that we are in right now is known as knowledge economy, and knowledge is what you get from the data. So data is the oil. Let's take this analogy: data is the new oil, and compare how things happen in both the worlds. You must have seen this slide quite often, and this is probably one of the most forwarded. Some variant of this is the most forwarded thing during the Mother's Day on the WhatsApp. But how many of you have noticed this? Geo is the mirror image of oil. Reliance is in oil and Geo is in data. So I don't know if this has been done on purpose or it has happened. I don't know, but this is what it is. Let's take this analogy further and let's find out how things move. In the oil industry, you mine oil using these kind of oil wells. So you have oil wells which mine the oil, which is in the crude form, which is mixed with so many impurities and all. Similarly, data is mined using sensors. Now here I have shown a transducer, a pressure transducer. Transducers are basically devices that convert one form of energy into another form. But the transducers have evolved into sensors. And sensors are basically transducers which convert one form of energy into a calibrated electrical impulse on the as the output. So these kind of sensors will give you either 0 to 10 volts or 0 to 5 volts or 4 to 20 milliamps or whatever. And then this becomes a sensor. Otherwise, it's just a transducer. So the sensors give you the data. Now this data is also like crude oil mixed with noise and you have to filter it out. So next you store the oil in temporarily probably these kind of tankers which move the oil from oil fields to refineries. Similarly you store the data in cloud and then it goes to oil goes to refinery. Similarly the data goes for analytics. The data per se without any processing is useless because it's just a collection of numbers. So unless you analyze the data, you won't be able to make use of that data. So analytics is something that is very important, and depending on the results of analysis, you get you can use the results of analysis for managing your business. That is what is required. Now for transferring, you need pipelines. Similarly, you have these kind of hardware devices to be put on your controllers, which can uh, connect the two devices together. Then you need pumps for transferring the oil from one place to another. Similarly, you need protocols for transferring the data from one device to another. So these are similarities between oil and data. Finally, this is the final useful product which you are using, and here is the analyzed information which you can use for controlling your business, for managing your business. Now, there is another thing that happens is the information that you get out of analytics and final products in oil. They are used for automating your businesses. Let's let's see. Hello, please mute your microphones. Here is one small clip where the automation in oil filling has been shown. This is an automatic petrol filler. He has paid the money and see what happens. $10, 110 kroners. There she can go. Right. Similarly, with the data, what you can, what from the data that is analyzed into information, what you can do is automate your manufacturing processes thoroughly. I'll show you one clip from Tesla manufacturing, and you can see instead a few critical operations where a human intervention is needed, only those are manual. Rest everything is automated. This is the press shop where the blanking is done. So you can see there are so many robots inside which do the transfer of components within presses. And this is changing of the die. Once the die is set, no one is, you will know, see no one here. It's completely automatic. And here you will see people doing the inspection, visual inspection of the components. Nowadays you get equipment which can probably replace even these people. But being a commercial vehicle, I mean, vehicle for personal use, there's still maintained people. Now this is a uh, fixture for assembling the chassis. There was the basic component of the chassis. And now you will find so many components being added to this. The chassis will, uh, the body will, of the this thing will be complete out here. Stage 7. Yes. Welded. Here comes our fully assembled body. It goes for painting. There is something called a 7 tank process through which this goes dips into various types of acids and alkalis and whatnot, and to clean the other. The phosphating also goes on inside, and you have a rust-proof material which is painted. And you can see those orange-colored PPEs the robots are wearing. They're meant so that the paint doesn't go inside the crevices on the robot itself. It's kind of a PPE for your robot. After the painting, you will find another manual inspection stage. Here it is being manually inspected. Then it goes for final assembly. Now here you will find batteries, wheels, controllers, uh, seats, all that getting loaded automatically. Only a few components are added manually. Just everything is automatic. Here comes the roof. Now this is a critical component, so it is being done manually. The dashboard. This is one process which people have not been able to automate even today. Wheels are getting attached. Here comes Samrita. Right. So this is, as I said, only inspection is manual, rest everything is automated. Now, we said that the problem with the current scenario in factories that the machines are not connected to the computers, to their IT system. There is a link in the form of shop managers or line managers who will collect the data from the machines and the equipment and then feed it to the computers on the shop floor or send it to the IT department and the IT department fills in the data. This is a typical factory setup. This white thing is the factory, and we have this inbound information in the form of orders and information regarding your supply chain and supplies and all that. And here is the outbound information uh, regarding the payments and deliveries and dealers and all that. This is the top management sitting here. And we have uh, support function management, supply chain, customer relations, quality management, engineering management, IR, manufacturing engineering, finance management, and so on. And all these are connected through this IT and systems management or ERP or MIS, etc. Now, this whole thing sits on top of the shop floor. Shop floor is the place where you actually add value to your product. All these departments on top do not add any kind of value to your product. The only place where value is added to the product is the shop floor. And it's the shop floor which is not connected to the system. It's through humans. And humans do err at times. They have the operations are being done by operators and they are being managed by managers. So they have some kind of linkage and some kind of human touch to the operations, which with industry probably will get lost. But then that's the price that one has to pay for getting them on time data. Now this link, this coupling between the computers and the machines is the managers. We want to replace this coupling with an automated system, and that will connect everything together, and then we will be working uh, in the current time all the time. But what are the challenges in that? As we saw that the basic challenge is the protocols. Thing is, IT and OT proliferated as two silos, as I said earlier, and IT had developed a protocol which IT incidentally moved ahead much earlier than the OT, and they had developed a protocol in the form of Ethernet. And the problem with Ethernet is it has got a lot of latency in the tune of milliseconds, which is not acceptable for OT. Why it is not acceptable for OT? Because in OT you are trying to run multiple access simultaneously to get a particular complex shape, typically required for machining the turbine blades of aircraft engines or turbine blades for the turbines, water jet turbines or whatever you need for generating electricity. All those turbine blades have a very complex shape, and to get that shape, and so the you have to run so many access simultaneously in sync with each other, and a delay of milliseconds, you'll never get the result that you want. Now, this research on this thing was going on in different countries like US, UK, Germany, Italy, France, uh, Spain, Japan, and all those companies came out with their own protocols. All of them, fortunately, found that Ethernet is good enough for the physical layer. So they maintained the physical layer and they changed the intermediate layers of the protocol. But the problem is that no protocol talks to each other. So a Fanuc machine won't talk with Siemens machine, a Siemens machine won't talk with a Fager machine, a Fager machine won't talk with a GE machine. That is the big challenge. How do we overcome this challenge? This challenge is basically, as I said, because the protocols have different speeds. The protocol from OT, they are very fast. The protocol from IT is a slow protocol. Now the crux is to manage the speeds of them together. And how do you do that? There is something called as the I showed you in the earlier thing of Industry 4.0 slides that there is something called as edge node device. So what is an edge node? Edge node is basically devices which cannot talk to each other because the protocols are different. We have we have people have developed something called as edge node device. Now you'll find that this edge node device will have multiple RJ45 ports here. So one of the ports is a standard Ethernet port, other port is a port configured for whatever the machine, whatever your CNC machine has got protocol, and that protocol is fed here. And then they start communicating with each other. The data from CNC is collected and given to IT. Schedules from IT come through this, and they are probably given to this OTU for starting and stopping and those kind of things. The machine shop is a complex place, right? And not all machines are CNC machines. We have a lot of legacy machines within the shop also. So you will find these connectors here. These connectors are used for connecting the sensors that you will be putting on your machine, and the data from those is also collected, and along with this, the data from coming from this port, it goes to your IT. Many times you have machines which are very old. Like my own machine shop has got a machine which is older than me, probably 70, 75 years old machine. It's still working fine. And if I want to collect the data from that machine, which has got just one motor and nothing else, I need to put the sensors externally and then put a edge node device and then collect the data and then feed it to my server or whatever, or the cloud or whatever I decide to. Now there are different types of configurations that we can have. I mean, the first thing that we said earlier in the slide that you collect the data and send it to the cloud. That was the basic idea. But with advent of technology, uh, the ideas changed, and the people wanted some kind of a smart edge node rather than just a dumb edge node. And what are the characteristics of the expected characteristics from a smart edge node? It's to monitoring the productivity. That's the first function, because all this is going on because you want to increase your output. Why you want to increase your output? Because you want to be competitive in the market. Why you want to be competitive in the market? Because the salaries are increasing day by day, and this was envisaged in Germany, where the salaries are pretty high, and they can't beat the world market. Even today, the German cars are the most expensive cars. So to mitigate that, they came up with this. So productivity monitoring is the highest priority in this. And then you have something called quality monitoring also, which is required, because we always say that when you want to go for any kind of automation, your processes must be robotized or robustized. Because if you don't have a robust process, you might end up with a lot of rejections. You know, garbage in, garbage out. That is basically because the programs are checked, cross-checked, and uh, no, perfected. But that doesn't happen with manufacturing process. In manufacturing, the parameters are so vast that it is not possible to uh, write a program and get a correct output for quality, because we have even the temperature, atmospheric temperature can play havoc many times. So your quality must be monitored, and so what we suggest is you have an inspection stage between every two production machines, and if something goes wrong, you just stop the line there. to avoid rejection. So productivity monitoring, quality monitoring, and machine condition monitoring. That is the third one that is very crucial for any kind of business, because your machines can go down, your machines can start malfunctioning, and they all contribute to your productivity and quality going down. So your machine condition must be monitored all through and through. And for that you have sensors like pressure, temperature, vibration, all those kind of sensors being mounted on your machine. And you monitor the availability of the machine, you monitor the condition of the machine. And these three, availability of the machine, quality, and the productivity counts, will give you something called as an overall equipment effectiveness, which is a statistic which talks, which gives you an overall idea of what is the condition of each equipment on your shop floor. Energy monitoring is another area which is needed, because if your machine starts deteriorating, you start consuming more energy. So this also can be an indication about your machine conditions. Then with all this, you need some kind of basic analytics. Why basic analytics? Because if you start collecting the data and dumping it on the server, you need a huge server space. That's one thing. Second thing is, you don't know which data is there, when it is. I mean, you, what are you going to do with that data? Unless there is a problem, you won't be searching that data. So what, and the cost of transmission, all that is involved. So people say that your smart edge node should have some basic analytics, and it will convert the data into information, and if needed, only the data would be sent to your server, or raw data would be sent to your server or cloud, and otherwise nothing would be sent. Things are okay, so you don't need to send anything. Then there is, what is expected is having some kind of alarms. See, like you have, let's take for example of productivity monitoring. Your cycle time is say 3 minutes, and the operator is not there for 15 minutes. There is no cycle start button pressed for 15 minutes. Obviously, you are losing the production time. So that alarm should go to your production manager or whatever, your supervisor, and those kind of things. Or your machine gets into some kind of unnatural vibrations, that alarm should go to your maintenance guy. So this kind of alarm generation is something that is expected from your smart remote devices. And right now you have a PLC or a CNC, and when you put a edge node, there are two different systems working simultaneously, and then there can be problem during the maintenance and those kind of things. So it's better to have one single unified uh, system with machine control also. So this is all that is. This is minimum that is expected from a smart edge node characters. Smart edge node. Anything smart in this Industry 4.0 parlance is something which has got internet connectivity. Nowadays, you get even smart sensors where you don't put wire to the sensor. It has got its own battery, and it emits signals through Wi-Fi, and you can pick the signals and use them. So the smart edge node is supposed to have some kind of connectivity, and to your Wi-Fi and GSM and GPS and all those things, right? So the simplest Industry 4.0 implementation, as per the original idea of was, you have a machine, you have sensors, and you have a dumb edge node which collects all the data, puts it to the gateway, and the gateway is something that has got IoT connectivity, and it sends it to the cloud, and the raw data is sent to the cloud, and whenever you need, you analyze the data on the need-based condition. But as we said, that it has got a lot of. This is very simple to implement, and to start with, this is a good thing to do. But to get better results, what you need is an ideal IoT solution where you have a smart edge node device, and you have a machine with some protocol which is being read by this smart edge, smart edge node. This is the edge node device, and you have the data that you don't get from this controller. You put additional sensors, and you sense that data too, and then analyze that data, convert it to information, and give some kind of alarms. And then you have a array which connects everything together, and it goes to your enterprise server or cloud storage or whatever. This link in between is quite a complex thing. Let's continue. So this is the link. You have equipment one, equipment two, equipment three, so on. In a cell, this is right thing in a cell. So you connect them to a cell server, and then the third thing is a shop, and you have many such cells, and all those cells are connected to your shop server. It is connected to the enterprise server, and it can also be connected to a cloud. Or so this becomes your gateway. Now this is the same represented in a different format. You have stock management sitting in the head office. You have support management function facility. You have R&D. You have IT facility. You have shop one, shop two, shop three, whatever. Each shop has got some cells, one, two, three, four, and they have equipments and machines, and all those equipments and machines are connected to the cell servers, and the cell servers are connected to your shop servers. The shop servers are connected to your enterprise server, and the enterprise server connected to all the terminals all around. So this is your gateway now, and it can communicate with the cloud if needed. Or the problem with cloud is latency is one area, security is another area. So it's recommended that most of the communication that takes place should be through wire, and that becomes much safer. So now you can afford enterprise servers within. Usually don't go in for cloud service. The advantage with cloud service is you don't have to spend on a server. So uh, the initial investment is reduced, but then it keeps on generating some kind of a revenue expenditure through and through, like paying EMIs for your house. Instead of buying a house, you are paying EMIs rather than for the house. So with that, let's conclude on something that Industry 4.0 is the way to go. Why? Because you want to be productive. Prior to any automation, it is imperative to ensure robustness of the process. That's what I've emphasized earlier also, that manufacturing process and management process should be very robust. Otherwise, you'll end up with a lot of quality issues. The real challenge is the seamless integration of IT and OT, and that's why you have devices like edge node devices which have come up to connect the two together. Increased productivity is the biggest advantage, giving the edge over your rivals. This is the reason why Industry 4.0 should be implemented by everyone, because if someone who is not as productive as you implements Industry 4.0 and goes ahead of you, you are lost. The jobs are going to move from mundane physical in nature to more sophisticated jobs like programming, analytics, high-tech maintenance, etc. So people will have to change their mindset and move to a different level altogether. Industry 4.0 gives us the opportunity to work in real-time data all the time. This is the most important achievement of Industry 4.0. We are in real time all the time. It lends itself for automation and amalgamation of both manufacturing and management processes. This is something that will lead to uh, autonomous factory. I mean, you have not just machines, but other equipments like your AGVs, your ASRSs, your robots, all connected together, and you can literally manufacture products without any human intervention. So Industry 4.0 is something which lends itself very easily for automation and amalgamation of both manufacturing and management processes. This is the ultimate dream of most of the companies to go in for autonomous factories where there won't be any labor as such. There are a few factories in Japan who do this. Uh, there are only 4 or 5 people just to monitor the operations. If not adopted, enterprises can lag in productivity to such a degree that they may even perish. Now, Industry 4.0 is a technical challenge. At the same time, Industry 4.0 is also a challenge on the other front that it's more of change management rather than just technology management. It is technology management coupled with change management because you are going to the operators and the managers on the shop are going to lose their freedom of playing around. So you have to first get them into confidence and talk to them about the changes that are going to come, and then implement all this. Because your technology can be managed by your technology partners. The way when you want to implement ERP or SAP, Oracle, or whatever in whatever or any other implement, to partners who come in and implement it for you. What you have to do is ensure that you get what you want. Similarly, when you are trying to implement the Industry 4.0, there will be technical partners who will be coming in and you have to ensure you get what you want. Right. Now there are some supporting concurrent technologies uh, which play important role in uh, Industry 4.0, but they are not part of the core Industry 4.0. I would say. Things like AI and ML. This is soon going to become part of uh, Industry 4.0 in analytics because right now the level of analytics that goes on in uh, edge node devices or anywhere is regression and those kind of things. But AI/ML is still not used very widely, but it's very much a candidate to enter the thing very fast. Cloud, as I said, when it started was when it was invented, it was just storage as a service kind of uh, thing, and now it has gone into cloud analytics and cloud computing and all sorts of things. It's got capabilities which can completely replace your IT department. AR, VR, MR, these are again technologies which are used for training purposes and SOP implementation and those kind of things. Additive manufacturing is something used for rapid prototyping. Some parts are manufactured using additive manufacturing, but very few. Very complex and specific parts, if they are there, it's profitable to go in for additive manufacturing. Nowadays, some components of even aircrafts are being done using additive manufacturing. The advantage is normal machining in normal operations. What you do is you remove the extra material. In additive manufacturing, there is no scrap. So the material required is exactly what is consumed. Then there are cobots, collaborative robots. They work together with humans. Cobots are something that work together with humans. They have sensors which can sense people around. They can sense forces applied to their arms, and they can just stop uh, them colliding with people. Then there are AGVs, the auto-guided vehicles. Today you will find helpers carrying material on pallet trucks or forklift trucks. All those things can be autonomously done using AGVs. ASRS is another system, automatic storage and retrieval systems, where the store part of your business will be automated completely. Big data and data science is something that you need for going in for AIML because the volume of data is so much that it needs to be cleaned and presented to your analytics. Blockchain is another uh, very innovative technology where it's kind of you know a multi-ledger thing and meant for security of your material and those kind of things. Uh, Thank you. And if you have any questions, I think you might have sent your questions to Tejas. Tejas, are there any questions?
Yeah, so I'll be moderating this Q&A session. So any questions, just please put it in the chat box so that we can. I will be asking these questions to sir. So yeah, you can
And
ask a chat box. Yeah.
in the meantime, can you play that video?
Yeah.
Hello, Tejas?
Yeah, so if I'm trying to play the video, the problem is that I will not be able to see the questions. So let's have a Q&A session first, and then
Okay.
we'll.
Fine, 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 fine.
I'm also sending you a link for the feedback of our webinar here. So all of you who have attended the session, please also fill the feedback form. Before that, you can ask whatever questions you have.
Yes, Chirag, what you are saying is absolutely right. In monopolies, you don't really matter. I mean, there is no competition. So obviously, it is meant for a competitive environment. Absolutely right. All the manufacturing sectors, all the manufacturing sectors are going to be benefited by this stage of industrial revolution because that's where you will go ahead. How fast will new models emerge? It depends on what is your condition at that particular moment. And there are companies with different levels at which they can adopt Industry 4.0. So adoption can be for some companies where there is automation, it's easier to adopt. Where it is the automation is not there, first they have to go in for some kind of automation and then they can adopt. And what do you mean by business models? I mean, I didn't get you.
I think what she means is the business models which include a lot of these technologies like AI. So how fast and how much time will it take to get to the
Uh,
situation
it's
that we are
it's
thinking of?
it's very difficult to say anything about the timelines because it's a ever-changing scenario and the goalposts are getting shifted all the time. So it's very difficult to make any kind of statement. What are the risks of an Industry 4.0 solution? I think there are no risks. The risks are basically managing your workforce, because workforce is something which is going to get monitored all the time, and manage if you don't manage your workforce properly, there can be a revolt. I mean, it could be problematic situation on the shop floor, and that's exactly what you are trying to avoid. Barring that, I don't see any risk as such in implementing Industry 4.0. How can Industry 4.0 increase among the locals? Uh, See, people have to be inquisitive. I mean, you can't uh, impose certain things on people. So people should be uh, now this Make in India is another uh, implementation of Industry 4.0. You have C4I4, which is again meant for promoting Industry 4.0. So there are mediums who are trying to do this. So to get, uh, it will reach people pretty soon. 4.0 yeah, full scale. As I said, the main challenge is you have to manage the change properly. If you don't manage the change, you can land up in problems, because people are going to lose their freedom of working in a particular medium. So, especially operators who have backing of their unions and all that, op- operator unions and all. So you have to be careful there. Most emerging businesses focus on. See, the days of monopoly are practically getting over. You have people who always come up with some kind of parallel technology. So um, you may, how much ever you may try to get into monopoly, it's very difficult to create a monopolistic business henceforth. So you will have some kind of competition all the time, whether you like it or not. So this, all right. I'll show you something. That was my uh, that was supposed to be my parking card. I'll show it to you right now. See, this COVID-19 pandemic has mandated that practicing physical health is as a must, and this is something going to be a problem for most of the industry, because if you want everyone to give a lot of space around every person, you need a lot of space, and space is a cost. Naturally, there is a tendency to reduce people. There is a tendency to go in for automation. There is a tendency to go in for Industry 4.0 kind of initiatives, because that is going to save you money. That is going to increase your productivity. That is going to create you good quality. So there is a big opportunity for today's students in near future in implementation of Industry 4.0. There is, without a doubt. And this was basically a very, I would say, uh, sketchy presentation about Industry 4.0. But if someone wants to go into a real depth of it, you can contact me. Uh, this is my email ID and my phone number. You can note it down. Abhijit.mahazani@gmail.com, and my cell number is 9822241220. So if you want to know more about Industry 4.0, you can contact me. And on my personal level, I uh, sponsor one project every year on this same subject. So So the areas that you need to focus are basically implementation, and there are quite a few companies who are still trying to develop remote devices. So that's another area where you can pitch in. Anirudh, uh, yes, you are right, and the people need to uh, learn new skills because that's where things are moving to. I mean, if you look at it, earlier people used to ride tongas and bullock carts. Now nobody does that. So those people have shifted to driving auto rickshaws. So it's a similar thing. You have to adapt yourself to the new normal, as people say nowadays, which is a catchy this thing, new normal. But I mean, that's what it's going to be. It's going to be a different normal. So people will have to shift their focus. I mean, their listening to the new normal. The way this COVID-19 has made us wear masks all through when we go out of the house, we'll have to shift from. There is no escape from that. No, not yet. Not yet. Repeat, not yet. Industry 5.0 concept is not there at the moment. But probably including people could be the theme. I don't know. I'm not. But at the moment, there is no such thing. Industry 5.0 concept. Is that all?
Yes, we can. I think we can conclude. So should I show the video right now?
Yeah, yeah. Go ahead. It's a video released by World Economic Forum on Industry 4.0 and covers much more implications of Industry 4.0. I mean, including environment and a lot of things. So let's conclude with the video.
We are wondering what is happening in the world. Everything is changing.
The very idea of human being some sort of natural conflict is really going to change. Our bodies will be so high-tech we won't be able to really distinguish what's real and what's artificial.
Inside our own heads is the matter in the known universe.
Superhumans? The original Industrial Revolution was driven by the belief that you could use steam engines to do all kinds of interesting things.
But that was followed by additional revolutions for electricity and computers and communications technology. We're now in the early stages of the fourth industrial revolution, which is bringing together digital, physical, and biological systems.
One of the features of this fourth industrial revolution is that it doesn't change what we are doing, but it changes us.
With the ability to visualize brain activity, for example, through a simple consumer-based EEG device, it gives us access to ourselves in ways that we've never before thought possible. It unlocks the black box that is the brain and enables us to really, truly be able to realize an identity that is aspirational.
There's now a scientific foundation for the effects of mindfulness on the brain, on the genome, on biological aging. When one does know itself, then you get the potential for a new renaissance that restructures itself in terms of our relationship to life, our relationship to the planet, our relationship to work.
We need a different economic model. By that, I don't mean capitalism versus communism. What I'm talking about is a shift in the system along the lines of the two big changes that happened in the 20s.
There is no sound.
That will live within planetary means,
Yeah.
will be fairer, and that will be focused as its key goal, not on growth per se, but on maximizing human well-being. And history tells us that a value shift is triggered by the creation of a new story about how we want to live.
I see the circular economy as something which fits very closely with mankind's goal to be innovative and creative and to always progress. We can use asset tracking, we can use IT, we can use 3D printing to enable this different economic model to recover material, feed them back into the economy, and really to decouple growth from the resource constraints we have.
The reason we live in cities is not different today than it was 10,000 years ago. Even if we have got networks connecting us, we still want to have places. This means the place where we work and the place where we live are much closer to each other. A city where we don't need to have good supply chains in order to produce things, but many things can be sourced locally thanks to 3D printing and robotics. If we're able to do something to transform cities, to make them more efficient, then the impact can be huge.
Think about the prospect of getting rid of plastics. We must not only be inspired or informed by nature, but actually use natural organisms with which to design products and building parts. Only instead of varying material properties, we're varying biological functionality.
Design is critical today because it's the first signal of human intention. The question of adding quality to quantity, it isn't a matter of simply circulating things that are potentially toxic. It's circulating things that are safe and healthy for all generations. So the goal is no longer, I want to be less bad, less monotonous, less unsafe, less unjust. It's really about a diverse, safe, healthy, and just world with clean air, clean water, clean soil, clean energy.
Together we are fighting to preserve our fragile climate from irreversible damage and devastation of unthinkable proportions.
If we think about the original Industrial Revolution, it was an energy revolution. I like to think of it as a kind of bookending of a period in human history during which we used fossil fuels, and it worked very well for us for a long time. But now we have to bring that to an end. We have energy technologies that can power our civilization: solar, wind, biomass. So then the question is, well, how do we get good integration? Maybe the wind is blowing in Denmark, the sun is shining in Germany, and now you can move that electricity through an integrated grid. You energy at all times.
Walking around, you do see different stuff, parts like the white marriage line. They use a lot of things that help to lift up and move things to the car. You just sit there and, program something, and it has its own set mind, so go ahead and do everything. And then as humans, we just come in and take the extra steps to help the technology.
It's not the cure-all for everything. There's definitely a lot of things where people perform the operation better, but certainly for the right applications, robotics are a huge improvement for the process.
The prediction of 5 million jobs lost by 2020 to technology is serious. It's not main question. Manufacturing, services, public health and education, these industries will still exist. The main question is, what will be the future of work? How will we define work? How will we share the wealth?
From the viewpoint of the labor or jobs, now we really need new education.
We're working with World in Motion and First Robotics, trying to encourage students from third grade all the way up through the end of high school. We had students make sailboats, and then we had them race them, and so they could see how quickly they could move. And they immediately went back and started to say, "Oh, I saw what happened. I'm going to go change this or that." And that was third graders.
I just given a prize to a kid of 18 years old that has discovered something really very, very unique. Came up with how to get better productivity and better yields for seeds of corn. And so he basically came with the idea that if you would perforate these seeds, you would get more food. And you think about it and say, but he didn't go to university. So how does he get all that knowledge? And he told me, I mean, I've been watching YouTube since the age of 12, and I'm so interested that I know everything about it. I've read everything about it. The world is really open to learning. The thing is, how do you give the incentive to your kids to do that?
It's this ability of digital technology to change outcomes, to truly empower people all over the world that can create a more equitable growth, because I think the world needs that.
Fourth industrial revolution has the potential to make inequalities visible, to make them less acceptable in the future, and hopefully to garner political support to take the necessary decision to reduce the gap.
But because of the recent advances in technology, we're beginning to have machines that can augment us in all sorts of interesting ways.
I was the first person in the world to be able to voluntarily move my legs while stepping in a robot by exciting the nervous system using electrical stimulators directly onto the spine. We believe that a cure will be possible if enough of the right people have the will to fast track a cure for paralysis.
We take two things from the patient. First, we take a three-dimensional X-ray and we extract the three-dimensional data out of that so we can make a perfectly shaped puzzle piece. And then we also take a sample of fat tissue from the patient so that we can extract the stem cells out of those. And we use those stem cells with this three-dimensional scaffold that we fabricate. And after 3 weeks, we have a piece of living bone that's ready for implantation.
Being able to use genome editing to understand the genetic changes that lead to cancer, and technologies like drug delivery, getting molecules into particular types of cells. There's a lot of excitement about being able to move much more quickly on this disease.
One of the things that I think is so essential to free and open societies is freedom of thought. And up until now, the conversation we've been having is around freedom of speech. Once we can access people's thoughts, access people's emotions, we have to create a space that enables people to think freely, to think divergent thoughts, to think creative thoughts. And in a society where people fear having those thoughts, the likelihood of being able to enjoy progress is significantly diminished.
We need to take responsibility at every level of society, from the individual and the personal to the institutional to the global, to adapt to these technological challenges and changes, which are redefining what it means to be human, what it means to work, what it means to be completely embedded in this world.
People always ask me if I'm an optimist or a pessimist. The technology exists. How do we get it and implement it at the scale we need at a price that people around the world can afford? Even though we have everyday problems we have to solve, we have to find a way to lay the foundations for the innovations of tomorrow.
Good morning, everyone. I am honored to have the opportunity to propose the word of thanks. We at IEEE are grateful to Mr. Abhijit Mahajani sir for delivering this wonderful session on Industry 4.0 that not only took us through the history of industrial revolutions, but also elucidated the various processes involved in the same. It was truly an engaging session that highlighted the importance of automation, which Industry 4.0 promises. I would also like to thank our organizing committee at IEEE Student Branch VIT Pune for their efforts into publicizing the event and ensuring the smooth flow of the session. Lastly, I want to thank all our listeners who have avidly attended this and helped us make this online event a success. We hope that you stay connected with us for more such sessions and activities. Thank you.
Thank you. Thank you.
So yes, this with this we come to the end of the webinar. We'll be sharing all the materials with you along with a recording of this in case you were not able to see any videos or were not able to connect at some point in time. So thank you